Good evening, everyone. Hope you can hear me. Uh, this is the talk about a new engine which is in the horizon, which we think is going to be a game changer in the near future. This is purely an automotive engine, so I would like to talk about how I came to be related to the automotive industry. I started quite early in my career with the automotive ancillary industry, to be specific, and as was the in thing at that time, I started my own enterprise, manufacturing components for engines. It was quite a good product in the sense that it was unique. It was a sort of an import substitution. And it went on for a few years, but unfortunately I had to shut it down, and it was a failure. And at that time, there was nobody to tell us that if you had to fail, you have to fail fast. At that time, the mantra was, if you fail, you try and try again. And so I did that and wasted a few more years as an entrepreneur. Ultimately, I went back into the corporate world. Some of the MNCs, American MNCs, recognized the experience that I went through as an entrepreneur. And so they said, why don't you start an enterprise in India for us? So I did that, and a couple of years later, another MNC said, we want to set up a manufacturing plant in India. So I helped them set that up as well in Chennai. The phase from managing a small-scale unit of say about 5 people to an MNC subsidiary with about 200 people and 200 crore turnover. This was a big change, and this was a big learning experience for me. And every time the entrepreneur spirit in me was trying to find out what is it that made companies successful. I came back with about 3 important criteria. Number one, I felt was for a company to be successful, it had to have a good product, a great process, or a great idea. The key thing about the product is that the company should own the proprietary designs of that product. And that is what helps the company to make more money. If you are a subcontractor to somebody, you will remain a subcontractor where the margins are very, very low. The second thing is resilience of the company. You have to build that over a period of time, I understand, but that is important in the automotive industry. The industry is very, very punishing. If you make a little error, it doesn't give you a second chance. It is also seasonal. I mean, there is a cycle. It used to be a 3-year cycle of up and down, but now it is almost a 1-year cycle. And the worst thing is that it is very unpredictable. So the company should be able to manage the lows and the highs in a very effective way. The last thing is for the company to have discipline in all its processes, be it a business strategy process, or be it a quality process, be it a financial discipline. In every aspect of the business, it should exercise great discipline. I find that a number of companies where, especially in the small scale and the medium scale sectors, when the people start making money, they start looking at other opportunities of making quicker money, and then they lose focus. Now, these are things that I learned, and after I came out of the company, I wanted to share it with people who might use them in their own businesses. But to my surprise, I one day got a call from a person called Dan Harris. He said, I'm calling from Manchester, and I work for a company called Libralato, and would you like to join our board? Now, this was a bolt from the blue. I said, I don't know the company. It's all the way up in Manchester in England, and I'm sitting here in Chennai. Why would they want me to join them on the board? So somewhere along the discussion, he also told me that it would involve some kind of an investment. So there was the small print. Initially, I was thinking that this could be, may not be such a good thing to do. But something told me that you could look deeper into that. So I went for a discussion. I had a discussion with the whole team of the Libralato's company, which is a very small team. It consists of 4 directors. What really took me by surprise was the amount of work that they had done with a small team. The main thing was they have a concept of an engine, and they were bringing it to shape, they were bringing it to production in a very, very phased, methodical manner. And at the same time, I also went and met the inventor of this engine, Dr. Libralato, who is by qualification an electrical engineer. He also runs a resort, but he does designing of the engine as a hobby. This is the person that we're talking about. Now, here I saw whatever criteria that I thought was needed for a successful company, and that made me decide to join their board. So I made the investment and then joined the board. Now, the main thing I was surprised was what really excited me really was this engine. It's a completely new concept. It's totally out of the box. You're going to see it in the next slide. But before I go to that, let's look at what is happening in the internal combustion engine that we use today. This engine has been in existence for over a century now, but the basic engine remains the same. We have added quite a lot of accessories to it. We've added turbochargers, we've added superchargers, we've added aluminum radiators, we've put in variable displacement pumps, we've put in electric fans. We've done a lot of things, and we even put a small computer to optimize everything. But the basic engine, which consists of the cylinders, crankshafts, pistons, valves, that remains the same. If you look at an engine inside the Ford Model T, you will find the same engine there. In fact, those engines look really beautiful because they had a lot of brass components, copper components, and some even had silver components. So what I'm getting at is there has been no disruptive change in the internal combustion engine. And from some of the studies show that this engine will continue for the next decade or more, because there is nothing in the horizon which will change this. Until, of course, somebody comes up with a complete electric engine, with a complete electric car, which could be provided to the market at an affordable price, and which would have the same driving comfort, which will have the same driving thrill, and which will have the same driving economics. But that is not there yet. Yes, we have the Tesla, but those are very, very expensive. Will it address the mass market? Probably not. So the technology direction is now towards something in between, what we call the PHEV. I'm sorry. The plugged-in hybrid electric vehicle. Now this has got both the electrical system, a motor and a battery, and it has also got a hydrocarbon burning internal combustion engine. Most of the driving is done with the electrical power, but when the battery runs out, it changes over to the IC engine. So the IC engine basically acts as a range extender, and that's where this engine we think was going to be really, really useful. Let's start looking at this engine now. It basically consists of, it's basically a rotary engine, similar to what you have probably seen as a Wankel engine. The Wankel engine and this are comparable to the extent that the power density is almost the same, the compactness is almost the same, but that's where the similarities end. The Wankel engine had a number of defects, which is why it could not come into the market in large numbers. This engine overcomes all those defects. Now this basically consists of two rotors, with a power rotor and a following rotor encased in this casting. There is a combustion chamber at the top, and this is the output shaft. The two rotors are mounted at different centers. That means when they rotate, they trace different orbits, and the orbits overlap each other, which is what creates the compression chamber and the expansion chamber. But this is still an internal combustion engine. So we can look at the animation now, which will probably explain a little more about it to you. To give you a little history about how this evolved, Dr. Libralato had conceived this idea sometime in 2008, and it took them up to 2011 to bring it to the first simulation stage. So the first simulation was done in 2011, which gave us some very good results. And that helped us to start building the first prototype. And the first proof of concept engine was made in 2014, and it was tested, and that's the test that you're seeing. It was done at Libralato University in UK. Now the test proved a lot of things, and it gave us a lot of information for the next stage of development. Number one, it proved to us that the thermodynamic cycle of this engine, which is entirely different from the four-stroke engine that you have, that this was feasible and this worked quite well. Now, the major difference between this and the existing engine is you have in the four-stroke engine a clear 4 faces that you put on a graph with almost like a rectangle. Here, there are 9 faces to that engine cycle, and all the 9 phases sort of occur concurrently. And one of the best things is that every rotation, all the 9 phases are completed, and you also have a power stroke for every rotation. That is what gives you the power concentration. The test also enabled us to set some very high objectives for the next prototype. What we decided was that we should achieve a peak thermal efficiency of something over 50%. The current engines, normal 4-stroke engines, they give us only up to 30%. You try anything beyond that, you end up with knock. We are targeting an emission of less than 50 grams per kilometer of CO2. And we are also targeting Euro 6 norms, which is quite rare at the first stage of the engine development. We are also targeting a cost reduction of 30% and a mass reduction of 50%. That is what the compactness of the engine is what enables us to do these last 2 things. And you will see how important that is for us. With these objectives, we have started building the Mark 4, Mark 3 prototype, and this is currently under development and will be tested sometime in middle 2016. What we also hope to get out of this construction of this prototype is, along with all the advantages that I mentioned just now, the noise reduction will be far less than the reciprocating engine by nature, because there are no reciprocating bodies. The vibration is also substantially lower, 70% lower. And inside the engine you have the components rotating, which generates enough wind, air circulation inside, so it kind of cools by itself, even though we are making a water-cooled engine. This is what helps us achieve better thermal efficiency. I don't want to go too much into detail, but I want to mention that the compression ratio is what is key to the thermal efficiency. As you know, this is directly related to improvement in efficiency. The compression ratio, what is possible here is 12.3:1, whereas in current engines you have 10:1. So the direct increase contributes to the fuel efficiency, to the thermal efficiency. The other point is the expansion ratio is also much higher in this design, in this engine by design. What we've done is the expansion takes place here, and so this chamber is much bigger than this chamber. So the expansion taking place is about 16.1:1. So that helps us take out more useful work out of the gases that come after combustion. This will be an enabling technology for PHEVs. As I mentioned earlier, there are two systems getting into the vehicle. So a smaller engine along with the battery powered motor will directly fit into the current engine bay. So that's a big advantage for vehicle manufacturers. The cost reduction of this engine will help us subsidize the electrical components and the motors, etc. The marginal cost will help us get back the cost in about 2 years or less. And of course, substantial reduction in fuel consumption and emissions. We also looked at what are the other technologies that are likely to come up in the next few years around the world. And market research has shown that there are quite a few which are under development, but none of them give us the tick marks on boxes like compactness, low cost, low weight, power density, lower emissions. All of them have certain advantages, but they don't meet all the advantages that we have in the Libralato engine. So we think this is going to be the future for PHEV vehicles, and we intend to bring it to the market by about 2021, and the initial volumes that we predict are about 125,000 pieces in a year. So in a few years, if you get a vehicle in India with a battery system and a hybrid system like the PHEV, be sure that it is going to be a rotary engine, and it will most likely be from Libralato. Thank you.